Okay, so in this video clip, we will take a look at the Cox-Ross-Rubinstein model again using VBA code supplied by Fabrice Roua. This code originally I obtained from the Volupta website, and that's now defunct. But we can copy it from the Vinegar Hill portal and then go into an existing spreadsheet that I have, Excel sheet that I was using before. And we can see that we already had this function here pre-written in. So in fact, I don't have to paste in. I could have just copied the code that's already here. So we have the code already here. I could have copied that and then went in and created a new module. So we want to insert module and then paste. And this time it's going to be different because I want to make one key change here, and that relates to the fact that I want to incorporate in dividend yield. So far we've neglected dividend yield, the Cox-Ross-Rubinstein model, or the original code coming from Fabrice didn't include in dividend yields. But okay, so let's just put in div, and that distinguishes this module then from the preceding one. Okay, so it's gone in, it's fine. If we look at this, it's we have our function. However, we shouldn't leave it like that because that creates a conflict between the two. Okay, so if we look at the function name here, it's CRR3, and this function is CRR3. So we should do some renaming. So we change here the name of the function. We should include a parameter input or an argument, so Q. So in the arguments we will enter into the function, we should have a holder, if you like, for dividend yield. And then only one small change has to occur in our VBA code here. We just have to put in Q here for the risk neutral probability specification. Okay, so that goes in, that looks fine. And then last but important, if I change the name of the function here, we should include the function's name, make that change down here as well, that's important. Okay, let's go back in then for a moment. And you can see here, if we don't have a value for dividend yield here, when we use that CRR3 function, there was no value for dividend. Okay, so that's got to change, right? And this value here, well, Black-Scholes did, right? We did include a reference to C6, and that's there. Okay, so let's, we don't need any longer to look at this convergence. We can remove that for a moment and just focus on maybe just taking our function. We can drag this across and then make one small change here. This should be Q. Now, initially, there should be no effect when I run this. It's let's just see what the issue is. Let's go back in. CRR3Q, we've Q here, RF, negative Q, and down here CRR3Q, and then make sure that there's no conflicts. Oh, that looks fine. Let's go back and see if we can get to the bottom of this. Okay, so what I neglected to do was to put in all the arguments for the options. Okay, let's do that. Let's hit FX here, and we put in the spot price. We can put in the exercise. We can put in the time period. Maturity is 1 year. Risk-free rate is 5%. The dividend yield is 0. and we have a volatility of 20%, so the volatility of the stock price return. And then N is 100 steps, option type. Now, for the moment, I'm just going to say, it's a call, okay? So C, and then here we'll call this American, although strictly speaking, I should be saying European, E. So we'll run that, and you'll notice that the value I'm getting here is quite close to, first of all, Black-Scholes, right? There's no difference between these two because anyway, this value is 0.5. So if I put in 0.5 here, 0.05, okay, we can look at the effect, and we're getting some proximity. So we get 757 here and 764. That's the same as before. Because there's no reference here to dividend yield here. So that's just constant. That's constant. Second thing is we have A here, so it should be E for European. Black-Scholes model only reports European values, so I should change that to E. We might observe the change in the value here. So it went from 764 now to 755. And if I increase the number of steps to 1,000, this value should converge a bit closer to the 757. So let's run that. It may take a second, actually quite fast. Okay, we got up to 757. Okay, so the Cox-Ross-Rubinstein model that we have here for the European, if I specify European, then I get the value close to the Black-Scholes. But if I put in the A here for American, we're going to get a slightly different valuation, and it's going to be a bit higher, right? It's going to be a bit higher. Let's run that. Takes a second, so we might pause. And you can see here we're getting 766. If I put that back to 100, it becomes 764. And if I change the value here to the dividend equal to 0, then the American option will be equal to the European option, will be equal to Black-Scholes. And so this option here, the American option would be equal to, I could say E for European, makes no difference. It's still 1043. And if we raise this number of steps to 1,000, okay, it will increase, and this should increase 1,000. Okay, this will be 1045 also, or 1044.8. Okay, 1044.8.5. So what's the main thing here is that we have included very simply, we've allowed, we've included here a value, a parameter input for Q. And so it's relatively easy to include in dividend yield into the Cox-Ross-Rubinstein model. Secondly, dividends are important when it comes to valuing American options. There's no difference between a European call and an American call if the dividend is equal to 0. If the dividend exceeds 0, then the American call option typically can be likely to be more valuable than the European option. But when dividend is equal to 0, European and American call options have the same value.